Okay, so this first part up here is f of x equals 3 all the way from negative infinity here, and then it stops at 0 and it is included at 0. How do we feel about that? Pretty good about that? Okay, now we got another piece here. The second piece. Come on, my pen's upside down. Doesn't write upside down. So again, let's pretend that this piece here just kind of went that way. It just kept on going that way. What kind of a function is that? What kind of a function is that, Maria?
An identity function.
Oh, well, almost an identity function. That's a really good that's an interesting thing that you just said there. The identity function is very specific. The identity function is y equals x, and that runs has a positive slope, right? Okay, so the identity function is the parent function of all linear functions, all lines. Can everybody see this as a line? It's a line. Okay, so Magic Bowl. Magic Bowl is asking. Maria, you get to answer this question too. What is the formula for a line?
Y equals mx plus b.
Y equals mx plus b. And m is the what?
What's rise over run?
Yes, slope. And b is the what?
Oh, the y-intercept.
The y-intercept. Okay, so looking at this blue line right here that I drew, because I extended it. Isabella C. What's the slope of that line?
Sorry, my mic wasn't working. The slope of the blue line?
Yes.
Is it I don't know.
Well, so let me ask you a question here. Is it a positive slope or a negative slope?
Negative.
It is a negative slope, right? Positive slope is going up the hill, negative slope is going down the hill.
Mm-hmm.
Are you okay with that?
Yeah.
Okay, so I got a negative slope. So I know that it's a negative number. So my m is a negative number. And I'm going, if it's rise over run, I'm going down 1 over 1. Down 1 over 1. Can you see that?
Yes.
So what's the slope then?
Is it just -1?
It is -1. Okay, so that's my slope, -1x plus, and I'm going to ask a question here of somebody else here. Clark, what's the y-intercept on that blue function that I drew here?
0.
It is 0. So -1x plus 0. So I'm going to just rewrite that as -x. But this function has a domain also. All right, I want the farthest left value of this little piece right here. Mia, what is the farthest left x value of that little piece?
0.
It is 0. And is that 0 included or not?
Not included.
It is not included because it is an open circle. So I go 0 here. And Mia, what is the farthest right value of that function?
-1.
Look again.
Infinity.
Nope.
Is it 1?
It's just one. We're looking at the X values, not the Y values. You're looking at the Y value. When you said -1, right?
Yeah. Oh, yes.
Right. Okay. So it's 0 to 1. And is 1 included, Mia?
Yes.
There we go. Let's see if we're right. Three if X is less than 0, so 0 to infinity. -X if X is between 0 and 1. So that's how we do it. How do we feel about that? Okay, kind of. Okay, you know what? We're going to try another. I actually have a hard one coming up here. I'll give you a peek at the hard one. That's a little peek, but we're going to do a little bit easier one first. Okay, but I didn't make it up yet, so I need to make it up. But these, it's harder for me to mess up because I'm just making a graph, and I can do that. Oh yeah, I can do this. I wish I had a different type of graph paper. Maybe that one. Oh yeah, that's better. Okay. So let's make ourselves an XY axis. And here's what we'll make the graph look like. We'll make the graph look like this. Yeah, this is going to be a little bit harder. Stop, come on. Don't pop up like that. Why you keep popping up? There we go. Okay, there's your graph. I would like you to get the equation, the domain and the range. Would you like to do this in groups? I'm going to send you in groups. Yes? You want to work together? You want to do it on your own? Try it on your own. Try it on your own. The next one, the harder one, will put you in groups. How we doing? We doing okay? Finished? Almost? Okay, that's fine. That's good. Are ready? Yes? Yes? Ready to give it a try? Okay, let's give it a shot. Here we go. Okay, so Juji, how many pieces do you see? Here, there you go. How many pieces in this function?
Wait, like, I'm confused already.
Okay. Well, I just count them, you know, I mean, like
The three.
yeah,
Yeah, three.
three pieces. Yeah. Okay. So let's give them names. Go away. Let's call this piece A, this piece B, and this piece C, just so that we can refer to them a little bit more easily. We don't usually do that, but that we're just going to do that for this function. Okay. So piece A. Come on now. There we go. Mary Rose. Piece A. What kind of a function is that?
Linear.
I think that's a line. I think it's a linear function. Yes. And did you get an equation for that function?
Yeah, for that one, I got 2x minus 4. Wait, that might be the wrong one. Yeah, that's the other one. Mine are different. I got negative 3x minus 2.
Negative 3x minus what?
Minus 2.
So negative 3x minus 2. I think that's pretty good, because if I took this line here and I kind of extended it, you know what? Let me just do something here. Red and dotted. Okay. If I extended this as a line, yeah, it looks like it would cross the y-axis right there at, well, you know, my line is a little bit off there, but yeah. No, that's right, like that. It would go about like that. Everybody see that? Can you see that? Okay, so my slope, it's negative slope, and I'm going down 3 over 1, down 3 over 1. So I have negative 3 is my slope, and my y-intercept is at negative 2 right here. So I have a negative 3x minus 2. And then Mary Rose, did you what did you have for the domain of that?
The domain, I had negative infinity to negative 1 with the parentheses.
Negative infinity to -1 with the parentheses. I think that's correct, because this line is going to keep going forever and ever and ever. And it's going to go up forever and ever and ever, but it's also going to the left forever and ever and ever. And then, but it stops right here at x equals -1. Is everybody okay with that? Somebody want to ask a question? Come on, ask a question. Tell me where you messed up. All right, let's try part B. Juji, you're just like on the hot seat today. Your little popsicle stick is just very sticky. So part B, what kind of a function is that?
I'm not sure.
Well, so we were looking at it earlier. Well, I'm slide 37, I'm up here. So I went through my library of functions, and it doesn't look like that, or 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 that, but it does look like that.
So a constant function.
It's a constant function, okay? So that means f of x equals some constant. So can you tell me what that constant is? Let's get to it here. Where are we? We're down further. Can you tell me what that constant is?
Would it be like -2?
And it's exactly what it would be, because that's the y value. It's just going -2. -2. And what is the domain of that piece, Juji? Farthest left x value, farthest right x value.
Oh, okay. So would it be -1, 2
It would. And are they included or not included?
included?
They are included because they're closed circles. Good. Good. Okay. Let's see if we can get somebody new and different here to do the third piece. Ariel, you here? Or no, Ariel, her internet was totally flaky. Okay. Brooklyn, can you help me with the third piece?
Yeah.
So what kind of a function is that?
I did y equals mx plus b.
Good, I think it's a linear function, okay. So what did you have as the function?
I might have done it wrong. I think I did. I put 1 over 0.5, which I don't think is right, as the slope. So let me look at it again.
Yeah,
is it-
slope is y over x.
Is it up 2 over 1? So
Yes.
2. So 2.
Yeah, so the slope is 2. So I got 2x, and did you extend it to get a y-intercept?
My y-intercept was 3.
Y-intercept 3.
Oh, 2.
Is that because it's starting here at 2?
Yeah.
Okay, so I want you to look at it a little bit differently, because it's not intercepting the y-axis here.
Oh, we should draw it down. Okay.
Why is this not going away? Why is my sound? Come on, what's going on here? Go away. Oh, that's weird. Okay, so if I extend this with my slope of 2, where does it intercept the y-axis?
-4.
That's right. So I got 2x minus 4. I don't know why this, can you see this sound thing here on mine? You can? Why won't it go away? Will it go away now? A little bit. Okay, so 2x minus 4. And what is the domain of that function? So I'm going to get rid of my line right here.
For the domain, I got 3 comma infinity in parentheses.
And I think you're absolutely correct. Very good. Because it starts at x equals 3, and it'll go to infinity. Well, that's really good. Good job. Do you want to, wait, I have a question here. Let's do the domain and the range. Did anybody do the domain and range? Nobody did it? Nope, didn't get there yet. Mary Rose, what did you get for the domain and the range?
I just did the range. I didn't. Oh, actually, I think my range is wrong anyways.
You think your range is wrong?
I don't know what I was. Yeah, I don't know how to write it, I guess.
Well, the range on this one actually, as I'm looking at it, is a little bit complicated. So let's just kind of look at the domain first. So the domain of my, I'm going to make a number line here. 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. And my first piece says negative infinity to negative 1. So negative infinity to negative 1. And then my second piece was negative 1 to 2. Yes, and I will explain that. Give me 1 second. Okay, my second piece is negative 1 to 2. So let's make that a different color. So that's negative 1, and this is included, to 2. And then my third piece is 3 to infinity. And that's not included. So I go 3 to infinity. So it looks to me like I'm starting over here at negative infinity. And I go all the way over here to negative 1. Now there's an open circle there, but then it's picked up by the red function. And it takes it all the way over to positive 2. So I go negative infinity to positive 2. And then there's a gap from 2 to 3. And then it starts up here at 3 to infinity. And I account for the gap with a union. How are we doing with that? Are we okay with that? We're okay with that. All right. A question was asked, why is the middle part of the function here just f of x equals negative 2? And the reason is because if I kind of extended this again, if I kind of just went like that, you know, kept on going out that way as a line, my y value is a constant of negative 2. The constant function is just the y value, right? And it doesn't change. It's just the y value of negative 2. My x doesn't matter. Whatever x I put into there, function is equal to negative 2. Okay, so let's just talk about the range a little bit. The range is a little bit funny on this one. I wasn't thinking about it when I did it. Okay, so actually, let me just write the domain. The domain, I did write the domain. The domain is down here. Here's the domain. The range is a little bit odd because my lowest y value is -2, but it's a constant. So my range starts at -2. And then I have a gap all the way until I get to +1. And +1 is not included. And then this goes all the way to infinity. So it doesn't really matter that this one is here also because they both go to infinity. So that is what my range would look like. Pretty good? Acceptable? Okay. So the next problem I'm going to give to you to take home.
Mr. Jenkins, I have a question
Please.
about the range for the last one.
Yes.
I understand the first part of it being -2, but can you explain the second one, the 1 infinity?
Yes. So I'm looking at this part of the graph. What's my lowest y value?
-1?
Okay, so this is really common, Mia. You're looking at the x value. -1 is over here. That's the x value.
Yeah,
But what's my lowest y value?
1.
That's where I get the 1 from. And then it goes, y values keep going to infinity.
Thank you.
Domain is x's, range is y's. Okay. So, so let's just test something out here. Hang on a second. I'm going to stop sharing for just a second. I need to look at something. No, come on, Mr. Jenkins, get your head together. Oh. Okay. Here's what I'm going to do with come on. Boy, my computer needs to be restarted. You know that? I want to see you. I'm not sharing. There we go. Okay, now I can share the screen. That's so weird. So I'm going to send this out as an extra credit problem on the test. Okay, kind of challenging. So I because I want to let you guys go. It's 2:30, and you know I don't want to even try and rush this problem. That'd be a waste of time. Sound okay? All right. So go have a nice rest of your day, and we will see you later. Okay, I'm going to put this in Canvas too. Okay. There you go.
Thank you.
You're welcome.